Hello everyone, welcome to the video lecture series of computer programming using C language. So we are in our lecture number 20. In this lecture we will be learning about different types of arrays. So before that I will be repeating about what actually data types is. We already learned in our previous videos about data type, what actually a data type is. Normally this specifies the size and type of a value, and the type specifies what type of data you want to store in that variable, right? So normally data types are divided into primitive and non-primitive. These things we already learned. And primitive data type consists of integer, float, double, and double, and non-numeric data type consists of character data type. So all this set, primitive data type set category we have already learned. Now we will be starting learning about non-primitive data types. Under that we already learned we have three types: array, structure, and union. So from this lecture onwards we will be learning in detail about this arrays concept. So array is also one type of data type which is called as a non-primitive data type, and these arrays are designed by using these primitive data types like integer, float, double, and char. By using these data types only we will be designing the arrays. So let us start learning about this arrays concept. So these data types are called as derived data types also. Why? Because by using these primitive data types only non-primitive data types are defined. So that's why these are called as derived data types. Okay, so let us start learning this arrays concept. Now why we need to go to an array concept? We have these data types already available, then why we need to go to the arrays concept? To understand that one, let me give you a simple example. Let us consider a variable which is of integer data type and its name is a. Now I have stored in a value called 10. Now again after in the third statement I have stored 20 value into a. Now I am trying to print the value of a. Now you will be getting an output of a equal to 20 only. That means what happened? Whatever earlier value we have stored in a, that has been overwritten with 20. Okay, but if you want to have both the values, then what is the solution we can have? We need to take two variables. One will be holding one value and the other variable will be holding the other value. And if you use two printf statements, then we will be getting the values of 10 and 20. Both the values can be displayed. That means we can come to a conclusion where a variable can be holding only one value at a time. That means with this example, if you are trying to store more than one value into a single variable, then what happens? The old values will be overwritten with the new values. So that means we can say like a variable can hold only one value at a time. But if you want to have a common single variable name, that means a same variable name, where we want to have an opportunity of storing more than one values with the same variable name, then that can be done by using your arrays concept. So by using array, we can hold more than one value with the same variable name. Got it? So that is the use of having arrays concept. I'll repeat again, arrays are used to hold more than one value. That means in this case 10 and 20 can be stored with the same variable name a. And how that can be done? By simply converting this a normal variable to a array variable. How that can be done? I'll show you. Okay, so we can say an array is a single name of collection of data values. That means with a single variable name we can have collection of data values, and all these values whatever we are going to store into that variable, all these values should be of same data type. Like we can store more than one value, that is obvious, but all those values should be of either integer or float or character or double. That means we can't have a mixture of data type values. All the values should be of same data type. That means, and all the elements whatever you are storing, that will be stored in continuous memory locations. So it is not like wherever memory is free it is stored like that. It is not like that. All the all the values whatever we are giving, like 10 values if you are storing with the same name and all 10 values of integer data type, then all will be stored in continuous memory location depending upon the memory size. Okay, so with this information we can define an array. An array can be defined as a collection of homogeneous data type elements. Homogeneous is nothing but same data type elements. So we can define an array is a collection of homogeneous data type elements. So we have three types of arrays. Normally it has been categorized into three types broadly. First one is one-dimensional array, second one is two-dimensional array, and third category is multi-dimensional array. That means from after 2, whatever you take, like 3, 4, any dimension array, that will be coming under the category of multi-dimensional array. So we will be learning about one-dimensional and two-dimensional array. Okay, so if you are familiar with these two, you can proceed with other dimensional array also. Now, if you want to work with any one of these types of arrays, you need to follow 2 steps. First step is always whenever you want to do work with arrays, like maybe it is one-dimensional array or two-dimensional array, you need to first declare that array and then you need to initialize that array. The normal way how we have done with variables. First we need to declare the variable and then we need to initialize the variable. Similar approach here also. We need to declare the array and then we need to initialize the array. Okay, so these 2-step process need to be followed, and let us start with a one-dimensional array. So one-dimensional array, the first step is a declaration part. So what do you mean by one-dimensional array is nothing but, in one-dimensional array we will be storing only one row of values. That means we will be having one row like this. I'll show you. We'll be having one row or only, and with one row you will be having a capability of storing multiple values, and all these values will be represented with one variable name that is called a. That means a can be holding, a is capable of holding now 1, 2, 3, 4, 5, 6 values. So we are storing one row of value. That's why it is called as a one-dimensional array. Okay, now if you want to have such an option of storing these many number of values with a single variable name, first we need to declare that array. How to start with the declaration? We need to tell what is the name of the array, and then we need to tell the size of the array. Array must be first we need to declare that array and then we need to and then we can proceed working with that. So always declaration specifies 2 things. First one is what is the name of the array, and then it specifies what is the data type, like means what are all the values you are going to store in that. Okay, so we'll see that one. The syntax for this one will be like this. So you need to specify the type, data type, and then you need to specify the name, and also you need to specify the size also. So always declaration talks about 3 things. Array name, in this example if you see a, and then you need to specify what type of values you want to store, all should be of same type, and then you need to specify how many values you want to store. That can be mentioned by using size. Okay, so you can see a simple example, and don't forget to mention the size here. So this is a simple example, int a of 10. So that means we are storing 10 values, all are of integer data type, and all are storing with a variable name of a. Right? So memory will be allocated according to this data type whatever you have mentioned. Right? And then if you are seeing here for this example, 10 memory locations will be allocated, each of 2 bytes because we have declared of integer data type. Integer data type size is 2 bytes. Right? So this is how declaration can be done. So size can be either numeric constant or a symbolic constant. You can directly mention 10, or else you can use a symbolic constant also. That can be done by using your hash define preprocessor directive. That means you can use hash define and can be defined as 20, and this symbolic constant can be used to mention your size. So any one of these 2 approaches can be used to mention your size. So this is how declaration can be done. Okay, so once you declare how the memory will be allocated, let us consider you have declared int roll number as 5. Whenever you declare like this, then what happens? Memory will be allocated. 5 memory locations will be allocated, and these 5 memory locations will be given an indexing. Indexing is nothing but the indexing always starts from 0. First memory location will be given an indexing of 0, second one 1, like that. So individual elements can be accessed by using this indexing. So first element is roll number of 0, second one is roll number of 1, 2, 3 and 4. So always you remember the indexing start from 0 to the size minus 1, whatever size you have given. Okay, so this complete thing can be accessed by using your roll number. So first element can be directly accessed by using your roll number. Okay, so this can also be represented like this. So if you want to have better understanding, you can also represent like this 5 elements, and this is the indexing. Got it all of you? So you need to understand indexing starts from 0 to size minus 1. So individual element can be accessed like this. Roll number of 0 if you write, then that is nothing but you are referring to this memory location. That means you are referring to this the value that is stored in this location. Okay. So initialization. Let us go to the initialization concept. We have declared and now we want to store data into the values. That means you want to assign some values into the array. So to do that, we have two options like compile time and runtime, like normal variables. Compile time is nothing but in the program itself you want to give the values. So to do that task, you can initialize individual array elements by using your indexing. The syntax is here. You can use array name, specify the index and then give the values. So let us consider this is the example. So let us consider you have declared a roll number with 5 values. Now then what we can do, we can initialize individual values by using this index. So what happens? A roll number 0th value, that means first value with 10, second value with 20. Indexing starts from 0 to, this is 4. Okay, this is 4. So indexing starts from 0 to 5 minus 1 which is 4. Now here we have 5 statements. So if you follow this approach, what is the problem with this one is, suppose if you give 100 as the size, then we need to write 100 statements if you are using this assigning individual arrays element approach. To avoid this one, we have the other way also, where declaration part whatever you write here and this initialization part can be combined and all the values can be specified with a single line instead of writing that many number of lines. So you can, this is the declaration part where we are not mentioning the size here. Using the flower braces, within this flower braces we will be listing all the values whatever you want to store. You can see here the same example whatever I have given. I have written int roll number and no size should be mentioned and all the values can be specified. So the number of values you use, that much of memory will be allocated automatically. In this case, the memory will be automatically allocated and no need to specify the size here. That many number of, here you have given 5 values, so 5 memory locations will be allocated automatically by combining the declaration and initialization. Okay, and if you want to read the values at runtime from the user, then you can use the scanf statement. Simply you can, if you want to read a normal variable, this is the approach we are following. But if you want to read more than one value into a single variable name, then we need to repeat the same statement providing the index. That can be done by using your for loop. So what we are doing, we are declaring a variable called int a of 5 and this variable is an array now which is capable of holding 5 values. Now we are declaring, we are using our iterative statement for, and this loop will be repeated 5 times and this indexing will be used here a of I. So for initially I value will be 0, so I value 0 is less than 5, which is true, it will come inside, and a of, here I value is 0, so the first value will be stored in a of 0 and it will be repeated, I value will be incremented and then again the condition is true, it will come here and whatever second value you give, that will be stored in a of 1 and then a of 3, a of 4. When once I value becomes 5, if the condition becomes false, it will come out of this loop. This is how 5 values can be read by using your for loop. So depending upon the size here, you can change this value. Now after reading the values, you can print the values also simply by replacing this scanf with your printf statement. Okay, so this is how one-dimensional arrays can be declared and initialized if you want to store more than one value with the single variable name. Now what are all the applications of one-dimensional arrays? Normally one-dimensional arrays are used to perform searching a list of items from the list or sorting the elements either in the ascending order or in the descending order. To do such type of applications, we will be using this one-dimensional array. So about these applications, we will be learning in detail in our future videos. So with this, we'll stop here. Today's lecture will stop here, where in the next lecture, we'll see about two-dimensional arrays. So once two-dimensional arrays concept is also over, we'll see the applications of one-dimensional array and two-dimensional array also. Okay, so I hope you all are clear with this one-dimensional array concept. Let us all meet in our next lecture. Until then, thank you all of you.